Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at AriserTalent, and AriserTalent is an e-learning platform where you can get the video lectures recorded by the expert faculty of the Kota. Now, whether it is from NTSE, CBSE, JEE and NEET, you will get a wide variety of range you are searching for, and apart from this, you will get the test series, class notes and the doubts section where you can post your doubt and the faculty will answer you within the 24 hours. So what you have to do, you have to just press on the bell icon and subscribe our channel for more amazing videos like this. So I'm Krina Dayani, welcomes you all, and in the physics we are going to start our new chapter, and this is actually a very interesting chapter of the physics, that is light reflection and refraction. So today we are going to start our new chapter light. But before starting that chapter, one thing you know that what is light? Light is a basic thing. All these things are giving us glow just because of the light. Everything is glowing around us just because of the one factor, that is light. So there is a separate branch of physics in which we are going to study about the light, and this branch is basically termed as a optics. So we have a branch of physics that deals with study of light. So optics is actually a branch of physics that is going to deal with the study of light only. So we have a separate branch in physics that is going to deal with the study of light. Now, this separate branch of physics is not only divided into the single part, that is optics, it is actually have the three classifications. So these three classifications are geometrical optics, wave optics or quantum optics. So we have the three branches in the optics because it is not limited only up to the study of light. We have to discuss or we have to study the different characteristics and different nature of the light. So basically optics is categorized into three parts. Optics is having a three separate classification. First one is geometrical optics. Second one is wave optics. And the third branch is quantum optics. So these are the three separate branches we have for dealing with the study of light. Now, this geometrical optics is having a very common term that you have heard about, that is known as the ray optics. Ray optics is a very common term we have aware about. So geometrical optics is also known as ray optics. So this is our ray optics. Second one is wave optics. Wave optics is also known as physical optics. So we can also call it as a physical optics. And third one is the quantum optics we have. So these are the three separate branches of the optics which is going to tell you the different nature of the light. Now, firstly, if I'm talking about the geometrical or the ray optics, so this optics is going to deal with the light and it is going to give you the phenomena of reflection and refraction. So it is the thing which we are going to study in the geometrical optics. So firstly, if I'm talking about geometrical optics, this optics will give you the phenomena of reflection and refraction. So what we are going to study in this topic? We are going to study about reflection and refraction. So these two important phenomena, that is our chapter name, we are going to deal in only one branch, that is known as our geometrical optics or ray optics. Now, after this thing, we have our second branch, that is about the wave optics. So the second branch we have is wave optics. Now, in this wave optics, what we are going to discuss? We are going to discuss about the wave nature of light and the few phenomena like polarization, interference and diffraction will going to be studied only by this wave optics. This wave optics is not a part of our class 10 CBSE or NTSE syllabus, but we have to study these chapters in detail in your senior classes, that is in the 11th and 12th. So this wave nature of light, only you are going to deal with about the interference, polarization and diffraction. So wave optics will deal with the wave nature of light, and in this we are going to deal with interference, diffraction and polarization. So these three important phenomena we are going to cover in the wave optics of the physics. Now, after the wave optics, we have the third branch of the optics, that is about the quantum optics. So quantum optics basically deals that light travels in the form of the quanta. Quanta means in the form of the small packets, and these are the photons actually we have. So this thing will going to deal with the interaction of light with the few atomic particles, and in this system we are going to discuss about the photoelectric effect. So quantum optics, third part is our quantum optics. And this quantum optics will give you the theory that is related with interaction of light with atomic entities. So, how light is related with the atomic particles or the atomic entities, this thing we are going to discuss in our quantum optics. So, I hope you have a clear understanding of these three branches of the physics, that how one single branch is divided into the three parts, that is the ray optics, wave optics and the quantum optics. So just copy this part from here so we can proceed to our next part. So this is the whole thing about the optics. Now moving to the starting of our chapter, the first question arises here, that what is light? So now the basic question that comes into your mind is that what actually the light is. We are talking about light, and what is light? So light is basically a form of energy. We can say it is an optical energy which give you the sensation of vision. It means all the things around us we are seeing just because the light falls in our eye and the reflection is produced. Now what is reflection? That we will deal in our further lectures, but first simply learn that what actually the light is. So firstly, light is an optical energy. Light is a form of energy and it is which energy? It is optical energy. So light is a form of optical energy which gives us sensation of vision. we are looking at the objects and we are able to see them just because of that only single term that is known as the light. So light will give you the sensation of vision, but different scientists will give a different theory regarding the light, that how actually the light behave is. So actually we have the 4 theories regarding the light. So we will discuss these 4 theories one by one. So the first theory in this concept is Newton corpuscular theory. So what Newton said about the concept of light, let's see here. So in theories of light, firstly just note down the names which are the theories that are associated with the light. So the first theory we have is Newton corpuscular theory. And this theory is known as the particle theory, because it is going to give you the particle nature of the light. Second one is wave theory, and the third one is quantum theory, and lastly we are going to discuss about the dual nature of the light. So the last theory is about dual nature of light. So these are the basic theories we are going to discuss in this chapter. So firstly, let's start with our first topic, that is Newton corpuscular theory. Now, what Newton say about the nature of the light? He said that the light is flowing, or the light is coming in the form of a large number of the particles with a very high speed, and these small particles are actually known as corpuscles. So we can conclude that the light is having a particle nature, and the concept of reflection and diffraction can be easily clarified with this Newton's theory, but it is not able to conclude or give any evidence about the interference and the polarization. So the first theory is Newton's corpuscular theory. So what this theory states, that this theory says that the light always flows, or light is always generated in the form of the small particles, and these particles are at a very great high speed, and these small particles are known as the corpuscles. So the statement here is light is having a stream of high speed particles. The particles are flowing at a very high speed, and these particles are known as corpuscles. So what we will call these particles? We will call this particle as a corpuscles. Now, if this light is flowing in a stream of a very small particles, this theory can conclude the phenomena that is taking place. This is known as reflection and diffraction. So the concept of reflection and diffraction has been verified by Newton's corpuscular theory. So what it gives? It gives the phenomena of reflection and refraction. So these two important phenomena can be verified with the Newton's theory, but it is failed to give the concept of interference, diffraction and the polarization. So the drawbacks of this theory has been overcome by the further theories which are coming after the Newton's theory. So this is all about the Newton's corpuscular theory. So just copy this part from here. Now, moving to our next theory, the next theory we are going to discuss is about the wave theory, then after quantum, and then after the dual nature of light. So, let's move to the wave theory. So, the second theory in this sequence we have is about the wave theory. Now, what wave theory signifies that according to a physics named Huygens, he said that the light waves are mechanical waves. It means if he consider any hypothetical medium, that is ether, he found that the light waves travels through this medium. But later it was found that the light waves are electromagnetic in nature, that is, it does not require any material medium for its propagation. So if I am considering the vacuum here, light have a tendency to travel in the vacuum also. So if the tendency of the light to travel in the vacuum, we can say that light is an electromagnetic nature. So the speed of the light in this vacuum is very, very high, and it is considered as a 3 into 10 raised to the power 8 meter per second. So the concept of interference diffraction are easily solved or easily proved by the wave theory of the light, and this part will be our chapter of our further classes. So until now or up to this level, we have to only understand that what is actually the wave nature of light. So according to Huygens, he considered light as a mechanical waves. He said that light is a mechanical wave, but later on it was concluded that light is an electromagnetic wave. Light is an electromagnetic wave, and if it is an electromagnetic wave, it does not require any material medium for its propagation. So light does not require any material medium for propagation. And if it has a tendency to travel in the vacuum, the speed of the light in the vacuum is 3 into 10 raised to the power 8 meter per second. So the speed of light in vacuum is 3 into 10 raised to the power 8 meter per second. So this is whole thing about the wave nature of the light, and its credit goes to Huygens, and Huygens gave the principle of wave theory of light. And on the basis of this theory, various phenomena have been proved like interference, diffraction and polarization. But this theory will not give any conclusion about the photoelectric effect, and the photoelectric effect is later proved by the quantum theory of the light. So now let's move to the quantum theory of the light. So our next theory is quantum theory. Now, quantum theory actually says that the light always moves or light always emitted in the form of the quanta. Quanta means it is in the form of the small packets of the photons. So this is the term quantum. So the quanta can be taken from this, that the light is always in the form of the small packets of photons, and that is known as the quanta. and this theory is actually given by Planck's. So the light energy, if is in the form of the photons, and if it is going to fall on the materials like cesium, they will going to emit photons from it, and this effect is known as the photoelectric effect. So this theory is given by Planck. This theory is given by Planck, and this theory states that light is emitted in the form of packets of photon, in the form of the packets, and these packets are actually the photons, and these packets are known as quanta. So this will be known as the quanta, and if this light is going to fall on any substance like cesium, the material have a tendency to emit photons, and this phenomena is known as the photoelectric effect, and this is proved by the quantum theory of the light. Now, the energy of these particles will be given by the formula E equal to h nu. The energy of these particles will be given by this formula. Just remember this formula because we have to apply this formula in numerical sometime. So here h is the frequency, here nu is the frequency, h is the Planck's constant. H is the Planck's constant, and this Planck constant we have a fixed value, that is 6.63 into 10 raised to the power minus 34 joule second, and nu is the frequency here. So I'm again repeating, whenever a light falls on a certain materials like cesium, they have a tendency to emit photons, and this principle will be known as the photoelectric effect, and energy of these particles will be given by the formula that is equal to E equal to h nu. So this is all about the quantum theory of the light, and this theory is able to explain the photoelectric effect. So all the drawbacks that are existing in the previous theories will be continuously solved by the upcoming theories. Now, after the quantum theory, we have the last point regarding the light, that is about the dual nature of the light. So just copy this part from here. Now, the next theory about the light is fourth thing, that is about dual nature of light. Now, dual means double. It means the light has the two natures, that is, one is the particle nature and other one is the wave nature, and this dual nature is actually given by a physics name de Broglie. So, who gave the dual nature of the light? De Broglie. And what does dual nature signifying here? Dual nature means the light has two natures. Dual nature means the light has two nature, that is, one is the wave nature and second one is the particle nature. So first one is the particle nature of light and second one is the wave nature of the light. So particle nature of the light, we have studied here that light is in the form of the small packets or photons, or it is in the form of the small particles. So this is the particle nature of light, and it is in the form of the electromagnetic wave. Now this wave nature of the light, that it is electromagnetic in nature, so this concept has been taken by Einstein, and the photoelectric effect was further proved by the Einstein by considering the wave nature of the light. So you have to remember one point here, that the light has two natures. One is wave nature and second one is the particle nature. So this is all about the theories related to light. So in our today's lecture, we have a description about the branch optics and different theories that are associated with light. So this lecture is over here. I hope this whole picture is clear to you. So for more video lecture, just subscribe our channel and just get an amazing videos like this. So thank you so much. We will continue with our next topics in our next lecture. Thank you so much.